All right, hello, math 30-1. All right, so we're on lesson 31, the unit circle. All right, so you guys probably won't have seen the unit circle yet. And it's going to be pretty critical for this entire unit. So probably if you were going to make sure you're paying attention to a lesson, it'd probably be this lesson. So, all right, put your thinking caps on. Okay, so the unit circle. So here's where we're at. If we have a circle where we said the radius was equal to 1, that's really all it is. So we have a unit circle, and there's special places where when we make the radius 1 that we can make life kind of easier. So here, I'll show you what I mean. So this radius 1 would be from there to there, right? This is on a Cartesian plane, so we can talk about points being on this plane. So if I set this point right here on this unit circle, well, that would be 1, 0 at that point, right? The x value is 1 and the y value is 0. Okay. If I went straight up with that r being equal to 1, right? Because this length that I just drew there would be the same as that length, right? It's still just 1 on our unit circle. Well, then it would make a circle, and then it would be 0, 1 at the top, right? And that would happen at 90 degrees, right? It would be a right angle triangle there. And if I went over to this side, then that point would be at -1, 0. And if I went straight down, that point would be at 0, -1, right? And that'd be at 270 degrees. Okay, so those are the easy numbers on the unit circle. The other thing that's going to be a little bit more challenging is we're going to stop talking about this in degrees, right? 0 and 360 degrees right there. When we're going to be talking about it in radians. So we got to do a little bit of math to kind of get this drawn out. So, why is it called the unit circle? Well, it's because it's 1 unit, right? We made r equal to 1 unit. All right. So if we go down, though, I just want to kind of show you, to start to figure out some other angles on this unit circle, I just want to kind of draw this one right here. Let's say this was at 45 degrees, right? This was a 45-degree angle right there. Well, what will happen is you can think about this as, all right, let's make this thing into a triangle, right? I can make it go straight down from there to there. Maybe I'll make my x value red, right? So I can turn that thing into a triangle, right? Well, if this was a right angle triangle that I created there, then you can see I've made a right isosceles triangle, right? This would be 45 degrees, and that would be 45 degrees. Well, if we go down here, there's something special about these 45, 90 triangles, right? So we can figure some stuff out. So let's draw I'll draw it the same way I drew that one, just so we're consistent here. Let's draw a triangle. Okay, let's say that this is 45, this is 45, and this is 90. All right. Well, right now, the only thing that I know about this, like the lengths of my triangle, is that I said this is 1, right? And the reason why that's 1 is because this is the unit circle, right? This length here would be 1, right? It's always 1 for the radius there, right? Okay, so I know that's 1, but I don't know what these sides are yet. I don't know what this side is, and I don't know what this side is. The reason why we're looking for those side lengths, is because this side length here, if I wanted to know what this point was right there on this unit circle, well, that side length there, right at the bottom, right here for the red, let's say, that would be my x value. That'd be my x value there, right? And then my y value would be this side of my triangle. That'd be that one, right? So that's why we're doing this. So let's go down and see if we can figure out those side lengths. All right, so what do we know? Well, let's call this x, right? That's going to be my x value. And let's call this side y. Circle the dots on there. Okay, now, if we set it up like that, hopefully you guys have a bit more room than me. What I'm going to do is I'm going to rewrite this out as, let's say, x squared plus y squared is equal to 1. Right? This is just a squared plus b squared is equal to c squared. So we got x's and y's. All right, so if we rearrange this, well, first off, are we okay with saying that this side is the same as this side, right? So I've got it written as x and y, but instead, you know what I'm going to do is I'm going to say x squared plus y is the same as x. I'm just going to call that x squared again is equal to 1. x squared plus x squared, this would be equal to 2x squared is equal to 1. So x squared is equal to a half. So then x is equal to the square root of 1 over 2. And just remember too that whenever you take a square root, you actually get the positive and negative version of that as well, right? So that's what this is telling us so far, is that we have, you know, this side length here and this side length here is both the square root of 1/2 and plus or minus, right? So that's what this would be. This would be the square root of 1 over 2, and this would also be the square root of 1 over 2, right? That's what we just found there. Okay, so that one's done. Now, there's like two more, well, yeah, there's two more angles that are going to be useful in our unit circle. So we just found 45, right, going up from there to there. The next one's going to be at 30 degrees. At 30 degrees, so like right there. And then the next one's at 60. And that's really all we do. And then all the way around the circle, we go like, you know, all the way around there. But if we find this point here, right, this one and this one, we should be pretty good to go. So what I'm going to do is that we can figure those out too from this 30, 60, 90 triangle. And what I'm going to do first, let's make a sixty triangle. Okay, so if I make that, the little trick I'm going to do here, I'm going to cut this thing right in half, right? I'm going to cut it right down the middle. Well, what that did now is I've kind of made a new angles, right? That'd be a right angle triangle there. This would be 60. But then this one here, that would be 30 degrees, right? That'd be 30 degrees. Well, that'd be perfect, because now I can use that, right? Because this triangle here, right, from here to here on my unit circle, this would be 30 degrees in here. Sorry, I'm really making it all messy, but that would be 30 degrees in here. So if I can do something with this new triangle here, I can find this side and this side, which would be my points when I actually write down my points there. All right, so let's see if we can do anything with this. So if I've got a triangle like that, here I'm going to just draw it again, but maybe on the side over here. Let's go. All right, so this is 60. This is 30, and that's 90. Well, let's see what we know about this triangle now, right? Well, what we know is that this is 1, right? That's what we were calling this, just by definition. We were calling these sidelines 1. So this would be 1, this would be 1, and this whole thing would be 1 as well, right? So I know this is 1 for my hypotenuse. And then I also know that this would be a half, right? I cut this triangle in half. All right, so I know my x value. So far, well, I'll show you what we're doing. We'll figure out the other side here first too. So then the only thing I'm really looking for here now is my, we'll call this b for now, right? I'm not going to call it x or y because that triangle could be flipped around different ways based on what we're looking for. All right, so if I'm looking for b there, let's write it out again. So we're going to have, let's just write out a squared plus b squared is equal to c squared. We'll just do it that way. And then I'm going to rearrange for b here. So I'm going to say b squared is equal to c squared minus a squared. And then if I fill some of these things in, right, because this was c and this was a, b squared is equal to, well, 1 squared minus, and then a was 1/2 squared. Okay, so b squared is equal to 1 minus 1/4, right? And then b squared would be equal to 1 minus 1/4. Well, 1 would be 4 over 4, so this would be 3 over 4. And so then it turns out that b, if I take the square root of both sides, would be the square root. Oh, you're going to split out here. We could do 2 steps. Let's say b is going to be equal to the square root of 3 over 2, right? I just took the square root of 4 on the bottom already. And then don't forget this is plus or minus, right? Plus or minus square root of 3 over 2. All right, so that's what this side of my triangle would be, right? That's what we just found. All right, so let's move on. I'm going to use those things now as in our unit circle. So, where am I even recording stuff? Where did my thing go? One sec. I think I'm recording. Huh. All right, I'm just going to assume I'm recording here still. Oh, there it is. All right, so you guys can read through that one just to kind of see what we're going to do here. But I'm just going to go right to the unit circle. And yeah, this is the start of it. And we're going to fill this in. I just want to kind of show you what we're dealing with here. So in the unit circle, we've got degrees, right? This one's written as 30 degrees right now. And then what is this? Well, that's also an angle, right? But it's written in radians instead. That says pi over 6 if you can't read it on yours. So pi over 6. And then here's our points, right? Remembering that this point, right, that's really our x value. And that point is really our y value. So, and another way of seeing this, like, you don't have to write this down, but let's say here, right? If I drew a triangle like this x value that's in here, root 3 over 2, that's this length on this side, right? It's going to be root 3 over 2. And this 1/2, well, that would be that side, it would be 1/2. If you're confused about where you got those numbers, that came from this triangle that we just did, right? That's just this triangle just flipped on its side, right? 30 degrees and 60 degrees. So this side would be 1/2, and this side would be, this side would be 1/2, and B would be root 3 over 2. So can you kind of see that is this triangle that we have here? The bottom would be root 3 over 2, and the top would be 1/2. We just flip the triangle around. Okay, so that's pretty much it. That's how we found all those numbers. Now we just need to find the rest of them. All right, so let's do this. So we've got 45 degrees would be the next one that's going to be interesting to us. And then we're going to have 60 degrees. So, and then here I'll do 90 up here as well. We'll just do this for now, and then we'll go all the way around here, okay? All right, so let's just focus on the angles for a second here, right? So 30 degrees or pi over 6, like what we got going here. So let's figure out 45 degrees. So 45 degrees, right? What we need to do for pretty much all of these, I'm not going to do every one. I'll just do a couple, and then it's all really the same thing, right? So this was what we've already learned in the last lesson, right? So if I've got 45 degrees, and I want to change that into radians, right? Well, I'll write a little bit different. I'm going to say x over 45 degrees is equal to, and then I just need a ratio, right? I just need some kind of ratio to figure this out. Well, what we say is that pi, 180 are the same, so we'll make our ratio pi over 180. Okay? So in the end here, if I'm solving for x, right, I'm just going to bring the 45 up. So you would get 45 over 180, and that simplifies to pi over 4. Right? So that's pretty much it. So every one of these you could fill in just by doing that. And I'm gonna skip that. And I'm gonna start writing these in. So this would be pi over 4. And the next one would be pi over 3. And then 90 degrees would be, well, half of pi, right? It's gonna be pi over 2. And then this ends up being, here, I'll go around my degrees first. So we're gonna do, this would be 120 degrees. This would be, I'm going to zoom in a little bit. So zoom 150. Okay, so 120 degrees, 135, 150, and then 180, obviously. Moving my way down. Let's go to 10. 225 degrees, 40, 7. Oh, I forgot to think about it. There should be a thing here too. So 240 degrees. Oh, 270. What am I doing? 270 degrees, I mean. You knew that, yeah. 270 degrees, 300 degrees, 315, and then 330. And then again, I should have done this one too, right? This could have been 0, or it could have been 360, right? If you go all the way around. So those would be the ones in degrees. Okay, so now let's go around. Maybe I should have made a different color. Do that from now on. Here, so I wrote green just a bit different so you can see it a bit clearer. So pi over 2 was 90 degrees there, we said. And then we've got 2 pi over 3. Remember, I'm just doing this, like, find these, right? I'm just doing the same thing to find every one of these. So I'm just skipping that step for simplicity. So 2 pi over 3, 3 pi over 4, 5 pi over 6, and then this one, famously, just pi. And then 7 pi over 6, 5 pi over 4, 4 pi over 3, 270 is 3 pi over 2, and then 5 pi over 3, 7 pi over 4, and then pi over 6. Okay, and then 0. It's still going to be 0, right? Or 2 pi, I guess you could say. 2 pi would be all the way around, right? But it'd be 0 radians as well, right? All right, so we got all that. The only thing I want to do now is I want to show you some patterns that show up. And here's the bad news. The reason why I'm showing you these patterns that show up is because we need to memorize this. Every year students are a little blown away by that. Well, we don't even need to memorize just this. We need to memorize these numbers that I'm going to show you how to find in a second here too. So yeah, so let's look at some patterns to help you memorize these things. So you can see I've got pi over 6 is my first one there, right? Well, you can kind of see, like if I look at this dot here, you don't have to draw this, but if I look at this dot here, right, on this side, and then I look at this one, right, from that side, that should have been 5 pi over 6 there, right? You can see that. So it's over 6, over 6. And then you can also see if you went to the next one that's just down from the x-axis there, right, over 6. And maybe you guys found this mistake I made already too. This should have said 11 pi over 6 for that last one there too. Sorry about that. So 11 pi over 6? Yeah, so it's over 6 though for each of those, right? Okay, and then you got the same kind of pattern here, right? If I look at this one, right? It's over 4, 3 over 4 there, and then 5 over 4 there, and then 7 over 4, right? And then this one, right? Over 3, over 3, 4 over 3, 5 over 3. So you can, hopefully you can kind of see that pattern a bit there. We'll be using it a lot, and hopefully you guys will start to memorize a few of those. All right, so we've got the angles, right? Those are the angles. So keep those straight in your mind because people often get, these things in radians that we just figured out with pi over 6, pi over 4. They get them mixed up with the actual points. So you gotta kind of keep those clear in your mind. So now let's figure out what some of these coordinates are. And the way we're gonna figure out what these coordinates are is just from those triangles that we found in the last page there, right? So I kind of showed you in the last one how we found this root 3 over 2 and 1/2. Let's do the 45-degree angle one now, right? So if I want to figure out what these points are, right? So it's going to be something comma something. Remembering that, this value here is my x value. So if I made this a triangle from here, right, to here, maybe I'll just bold this too for a second so you guys can see it. The blue line there, that's my x value, right? That's the one that's going to go in there. The green line, that's going to be my y value, so that'd be the one that goes in there. Okay, so let's figure out what those are. This is just a 45-degree angle, and just to remind you, a 45 triangle, we figured out that each of those sides would be root 1 over 2. Right, so root 1 over 2, so that's easy enough, right? Both of these is going to be square root of 1 over 2. But, I guess I should have done that too. It's going to be the square root 1 over 2. The only thing is here, sorry, I should have done this before. If I've got the square root of 1 over 2, or if I could rewrite this as 1 over root 2, right? Just because I just took the square root of the top and the bottom there. I don't like having the square root in the bottom. Does anyone remember what that's called when you got a square root in the bottom and you want to get rid of it? It's called rationalizing, right? We need to rationalize the denominator. So I'm going to multiply the bottom by root 2 to get rid of that. But I can't just multiply the bottom, I also have to multiply the top. So in the end here, right, if I multiply this all together, we end up with root 2 over 2. Right, so this is the way that you would see it on the unit circle, and the way we'd write it instead of this way. Okay, so we're just going to put both these points here in as root 2 over 2. Root 2 over 2. Okay, for the x and the y. All right, so then the next one, we've got a 60-degree triangle. Well, that's really the same thing as a 30-degree triangle, right? So this triangle here, right, that we had before to find these two ones, it's like the same thing, right? Because that's the 30-degree angle, and that's the 60-degree angle. So this side here was root 3 over 2, and this side here was a half. That's how we got those numbers. It's the exact same thing, but it's just the triangles flipped around. If I've got this triangle going on, right? Now the x value is going to be a half, and the y value is going to be root 3 over 2. So that one's not too bad. It's always going to be the flip of this one here, right? It's going to be the flip of that. Okay, so we did all the hard work. Now the rest of them are all just different, like negative and positive variations of those points, right? Okay, so first though, let's remember what this one was. If I go to this point here, right, if I had a line going straight up and down to that one, well, now I've got an x value of 0, and I've got a y value of, remember the unit circle is a radius of 1, so that's 0, 1 at the top. Now looking at this one, right, this is going to be, well, this is just, again, 30 degrees from there to there, right? So we got the same type of thing happening, but if I drew a triangle again from, different colors so you can see it, from here and there, you know, did a triangle like that. Well, in this case now, right, this will be a half, and this on this side, this is going to be root 3 over 2. So my x value is a half, my y value is root 3 over 2. But the only thing we have to remember here is that this isn't a half. It's negative a half, right? We're going the other direction now. We're going to the left. So this is going to be negative a half. And then this is root 3 over 2 going up, right? This will be positive root 3 over 2. Okay, so we got that one. And you can probably see what's going to happen here. All of these x values are going to be negative, and all of these y values will be positive, right? Because y's are above the x-axis, and our x values are negative because they're to the left of the y-axis. Okay, so I can probably just fill these in now. So, making my brackets here, it should be the same as this guy, right? This is a 45-degree angle from there to there. Hopefully you guys aren't writing all these lines too. Maybe it would help, I don't know, maybe it would help here, but okay, so it's going to be root 2 over 2. They will both be root 2 over 2. But like I said, it's going to be just a negative on the x value. Okay, and then this one is going to be the same, root 3 over 2 and a half, but again, it will be negative. Okay, and then this one all the way around, right, on our unit circle. This point here would be an x value of negative 1 and a y value of 0. Okay, now this one, so you can see it clearly again. Drew a line from there to there, right, and went up and then over. I'm really expecting that both my values will be negative here, right? I'm going to have negative x coming this way, and I've got a negative y coming down. The longer side of these triangles was always my root 3 over 2 one, right? So my x value is root 3 over 2, and it's negative. And my y value is also going down, and it was a half, right? And I would expect that it would be the same as the one above there, right? It's like the same triangle, it's just flipped. Okay, so I'm just going to go a little quicker here now. Oh, sorry, that was negative. Said thanks like myself. Okay, so then negative root 2 over 2, comma, negative root 2 over 2. And then this one should be negative a half, comma, root 3 over 2. Sorry, that was negative as well. Okay, and then the very bottom here, this would have been an x value of 0 and a y value of negative 1. And then this one here, we should have, well, it should really be the same as this one again. So, but in this case, if I drew a line from there to there, right, made a triangle like we were saying, then our x value would be positive, and just our y value would be negative. Okay, so our x value should be a half, positive a half, and our y value should be negative root 3 over 2. Now erase this. Okay, and then these ones are always root 2 over 2. All right, and which one? It should be positive x, negative y, and then it should be root 3 over 2, comma half, and it should be negative that. And then all the way around here, we could have said that this point would have been 1, comma 0. All right, that's it. Hopefully you guys had this entire thing memorized. Okay, yeah, you're gonna have some time to do that, but just see the patterns, right? So we went over some of the patterns with the angles. They might be a little bit tougher to memorize, but these ones, like you've only got really three numbers to memorize, and then you just need to know where they're negative and where they're positive for these points, right? All right, so that should be it. Hopefully that wasn't too long, 27 minutes. That's not too bad. All right, for homework, make sure you guys do your questions, and that's it.